An electrical circuit is defined as a closed loop of electrical components around which a current can flow driven by a potential difference. Now, if you have a look at this circuit, the wire will have delocalized electrons in the wire, and the current measured in amps is the rate of flow of charge, and the potential difference in volts is the work done on the charge. Now, because a battery has a positive end and a negative end, it will produce an electric field. So, when a battery is connected into a circuit, the excess of positive and negative charges at the battery terminals cause an electric field to exist in a circuit. Electrons in a circuit have electric potential energy because of the distance from the electric field. It will have a potential difference. There's a difference in electrical potential energy. So a potential difference or voltage between any 2 points in a circuit. The charge gains electric potential energy as it passes through the battery. This is transformed into other energy forms as charge moves around the circuit. So if you look at the diagram on the left, you've got two positive charges. Now naturally they will repel. So that means if you look at A and B, the particle B will be repelled from the particle A. They have the same charge. So what happens if you push particle B towards particle A? You need to put some work. It's like if you imagine two magnets, you've got two south poles. Naturally they will repel, but you need to put some energy in to make them closer together. In this case, you need to put energy into particle B to move closer to particle A, because naturally they will repel, so you need to put energy to move it closer. Now, why are we talking about this? Because if you are pushing particle B towards A, what will happen if you release if you look at this the second diagram on the bottom? So now that the two positive charges are closer together now, what would happen if you release it? Now, because they naturally repel, think about an elastic band. As you stretch it, and then suddenly you release it, it will be fired. It would go into a projectile. It would fly away. It would go into a trajectory, meaning that because it will gain kinetic energy. You've stored the elastic potential energy, and then that will transform into kinetic energy. So alright, so what happens when you push the particle B, which is positive, towards particle A? You need to put some work because naturally they will repel. Now, as the positive charge gets closer together, particle B will gain electrical potential energy, because when you release it, it would suddenly be repelled. Because the closer the two positive charges are together, the greater the repulsive force and the greater the electric potential energy. So meaning that it has the potential energy to go somewhere. So this is what the diagram represents. So if you have a line further away from particle A, that will be a weaker force of attraction. And as the particle gets closer towards another charged particle, it would experience a stronger force. Alright, so separating positive and negative charges creates an electric field with stored energy. The battery has separated charges, so it always has an electric field around it. When you hook the circuit, the battery's electric field pushes and pulls on electrons on the surface of all the wires and the bulb filament. You end up with patches with more electrons and patches with less on the surfaces. That uneven electron distribution on the surface of the wires is a form of charge separation, so it creates another electric field. This second field is inside the wire, pushing the electrons in the wire towards the positive terminal, so this second electric field is what causes the current to flow. Alright, so a battery or another energy source causes an overall movement of charged particles around a simple circuit. When the circuit is composed of metallic materials, the moving charged particles are called electrons. So the battery pushes electrons in the circuit away from its negative terminal and pulls them towards the positive terminal. The energy of the battery to pull the electrons comes from the chemical reactions occurring within the battery when it is connected in a complete circuit. So it is the chemical reactions that is inside the battery that is creating a negative end and a positive end. So because the charges are separated, now that creates an electric field. Change at any point in a circuit affects the whole circuit. Because of their position in the electric field, electrons in the circuit have electric potential energy. As electrons move in the circuit, the electric potential energy is transformed into heat, friction, whatever useful forms of energy the circuit devices are designed for. So if you look at this diagram of a battery, remember if you have a positive charge and a negative charge and they stay at opposite ends, it does create an electric field. So this is the electric field of a battery, where the positive charge is on the right hand side, the negative charge is on the left hand side. Remember, the positive charge would point outwards, the negative charge would point inwards by convention. So if you were to have a positive outside this battery, it would follow the arrow. So for a conventional current, it would flow from the positive end going all the way around to the negative end. So if you look at this diagram here, just to zoom out, so the conventional current is where you have positive charges, but actually you have negative charges going around the circuit. So just remember that conventional current is positive charges going around, electrons is negative charges going around. So in this case, the conventional current is pushed by the battery's positive end because of the electric field. So the conventional current is being repelled by the positive side, and it will go towards the negative side. But actually it is the electrons. The electrons are pushed away from the negative end, and it wants to go to the positive end of the battery. So an electron at the negative terminal will be pushed away from this terminal and pulled towards the positive terminal if the battery is connected into a circuit. The excess charges on the battery terminals create pushes and pulls simultaneously on the electrons all around the circuit because of the electric field. So in the battery, chemical reactions are taking place and the voltage remains the same. Now, when we're talking about electric potentials, think about the two particles. So here you got the big blob of the positive charge on the top left, and then you got the two smaller positive charges at the bottom. What happens when you push the particles that are positive towards the bigger positive charge? So at the closer the positive charges are towards the bigger positive charge, the stronger the repulsive force. For example, it's also the same for negative. Although it is now attractive, the force between a positive and a negative, it still has the same force. But the closer the negative charge is towards the positive charge, it is the stronger the attractive force. So this is just talking about the change in potential energy. When you're moving from A to B, so imagine that the positive charge A, so you're starting at A and you've got a positive charge and you're moving towards the positive end. You need to put work because naturally the positive charges are repulsive. So you need to do work to move from A to B. Alright, so the electric circuit. Now here, the I stands for conventional current because it's going from positive to negative. So this is conventional current. And why do we use I equals V divided by R? We use Ohm's law. Ohm's law is when you increase the voltage, you increase the current. So if you think about the voltage, meaning the stronger the electric field. If you have a stronger electric field, the current will be pushed away from the positive terminal and it goes towards the negative terminal. Alright, so the symbol for a resistor is that rectangle where that says an R. So R is the resistance measured in ohms. Now the resistance means what's stopping the current to flow. So they could be obstacles, there could be impurities in the wire. They could be, so for example, an insulator would have a stronger resistance because there are no delocalized electrons. Now, when components are connected in series, the same electric current flows through them. This is because of the conservation of charge. The charge at one point in a series circuit must be the same at another point in a series circuit. The boxes just represent the resistors. It's just like a rectangle, so it represents the resistors. So in a series circuit, it is the same current that flows through the circuit, the same electric current. So because of charge conservation, current cannot disappear. Now, when components are connected in parallel, the same potential difference drops across them. You can think of the potential difference as voltage. So if we have a parallel circuit, have a look at this parallel circuit. Now here in this parallel circuit, you've got 3 loops. In a series circuit, you've only got 1 loop. So in a parallel circuit, you've got 3 separate loops, and the voltage across each of those resistors will have the same potential difference drop across them because you treat them as separate loops. Points connected by a wire are at the same voltage. Okay. When there is a junction in the circuit, the inward and outward currents to the junction are the same. So the junction is where they split up. When the current goes into that junction and they split up, the total currents coming out of that junction must equal to the current going into the junction. So again, this is because of the conservation of charge. Charge must be conserved. So charge conservation, current cannot disappear. So if you look at this diagram here, consider the currents I1, I2 and I3 is indicated on the circuit diagram. If I1 is 2.5 amps and I2 is 4 amps, what is the value of I3? So if you look at I1 is 2.5 and then I3 is 4 amps. However, I3 is more than the current going in. So that implies that I3 must be in the negative direction. Now, in reality, the situation is not possible because, mathematically it would be worked out already. So I3 should be pointing in the opposite direction. So mathematically, the answer is 3, but the answer is actually 5 because the situation isn't really possible, but mathematically the answer is 3. Alright, so a 9-volt battery is connected to a 3 ohm resistor, which is the incorrect statement about potential differences voltage. Now if we look at statement A, so that means the voltage difference between points A and B must be 9 volts. Now if you look at the battery, that's where the battery is placed. The battery is placed between points A and B, and it is a 9-volt battery, so 9 is correct. Sorry, statement 1 is correct. If we look at 2, the voltage between points B and C is 0 volts. Now, the voltage between the 2 points of a wire are very low. It's not the same as the voltage between a battery because energy aren't used up that much between 2 points of a wire, of a metal wire. So it looks like 2 is correct. 3. The voltage between C and D is 9. So there's a component between C and D, and it is using up a lot of energy. Components use up energy. and it seems to be using up the same energy as the battery. So 3 looks like it's correct. And 4, points D and A, the voltage between them is 9. Well, if you look at points A and D, you've got just a metal wire. There aren't any components between them. So metal wires don't use up that much energy. So it looks like 4 is incorrect. Okay, so if you have two resistors in parallel, you just add them together. It's the total. I mean resistors in series, not parallel. Resistors in series. Resistance. If you think of them as turnstiles going towards a supermarket, because they slow you down, when one turnstile goes after the other, it is cumulative, meaning that it adds on, the resistance adds on. So if you have two resistors in series, you add the resistances together. Now what happens if you have two resistors in parallel? Now because the current is split, the resistance, the total resistance will be less than the the lowest resistance if it was separate. So if you have resistors in parallel, the total resistance will be less than the lowest resistance if you treated them separately. So this is the equation. 1 over R total is equal to 1 over R1 plus 1 over R2. If you look at this reasoning here, now imagine the resistance of a component means that, let's just say that you're on a road and the resistance represents one of those booths, before you go to a different country, let's just say. So you've got these stop checks. So for every resistor, for every 3 cars, only 1 car can go through along this road per minute. So if you look at the top, let's just say that you're starting off with 18 cars. So for every 3 cars, only 1 car can go through. So if you started off with 18 cars, that means 6 cars will be stopped. And then another one, for every 3 cars, only 1 car can go through. So 6 cars are stopped per minute, and then the one further along is another 6 cars stopped per minute. So how many cars come out of the road? So 18 minus 6 is 12, 12 minus 6 is 6. So you end up with 6 cars coming out of that road per minute. Now let's have a look at the parallel one. Again, each of those resistors, for every 3 cars, 1 cannot go through. However, if you look at the 18 cars at from the left, and it splits off. So although you started off with 18 cars, the current is split before it comes to the resistor. So even though it is 18 cars and then it splits off into 2 lots of 9, where the road where that says 9, because 3 can't go, because it says for every 3 cars, 1 car cannot go through. So 3 can't go along that road, and then 3 cars can't go along the bottom road. So that means 9 minus 3 at the top road is 6 cars, so 6 cars can go through the top road, and 6 cars can go through the bottom road. And 12 cars, that means that total of 12 cars will go out. So that's what it means. Because you have resistors in series, the resistance is added, it's cumulative. However, if you have resistors in parallel, because the current is split before it goes through the resistor, it's a lot more. So a lot more current can pass through. So in summary, for a series circuit, the current is the same. For a parallel circuit, the current splits up. For the voltages add up. So for the series circuit, the voltage across R1 plus the voltage across R2 plus the voltage across R3 will add up to the battery voltage. For the parallel, it is the same voltage across the parallel branches. So for R1, it will have the same voltage as the battery. For R2, it will have the same voltage as the battery, and R3 will have the same voltage as the battery. The resistance in series, you add them up. And then for the parallel, the resistance, you need to use that formula that I showed you. But because you've got the resistance in parallel, the resistance will be reduced.